or a passionate industry technologist with a lot of experience, both on the tech side and on the business side. And he's currently Vice President at Musalasoft.
Thank you.
Thank you for being with us. Now, I like these panels. They serve as a bit of a digestive after lunch. You get to hear professionals talking, and you don't necessarily need to absorb slides. You're free of distractions, or you can create your own distractions in this case. But the topic is actually quite interesting. When I was asked to moderate this panel, what jumped out of me is that we do talk a lot about IoT, of course, but not so much about edge. Let's start and explore that. And Brandon, you're next to me, so I'll start with you. Why do we need to care about edge at all? What is this edge or way of doing computing close?
Yeah, it's a great question. You know, edge can mean a lot of different things, and it is one of these terms in the IoT space that tends to get thrown around. But you know, edge is the reason why IoT solutions exist. These are the devices that are actually sensing and actuating. That's the beginning and the end of the story. An edge device reads from one or more sensors, controls from one or more actuators, and that's the purpose of many IoT solutions, turning a machine on or off, you know, checking air quality in a device or something along those lines. Where things tend to get hairy or complicated, or where controversy arises, is when we start talking about edge sensing versus edge computing. And there's definitely been more of a trend lately in the IoT space where people will push for, well, we've got smarter microcontrollers and single board computers than we had 5 years ago, so we've got to push everything to the edge. Let's run every single thing that we can do in the edge. And I think, as my fellow panelists will dig into in a few moments, there's definitely a continuum of the kinds of things that you want and can and even should do in the edge. But I think you care to start with, because that's where the magic or the work of IoT happens. And then from that point beyond, it's a conversation around how much work do you want to do beyond sensing and actuating inside of those edge devices.
And I believe you started great with the definition, and we should put some framework and context around our discussion, because just as edge is ambiguous, IoT is also ambiguous. When we talk about IoT, often we mean consumer IoT, or sometimes we mean industrial IoT, the stuff we do in factories, smart cities, whatnot. So Simon, do you agree that what Brandon just said is valid in the context of consumer IoT?
In a sense, it definitely is, because if you join my talk, that's what we are currently doing. We have this gateway which is interacting with the devices, which is connecting to the internet at the same time. However, when I look at the trends that are currently happening in the consumer IoT industry, is that more and more manufacturers are going through the cloud again. So they're removing capabilities from the edge devices actually, and more products are moved towards cloud-based APIs and cloud-connected devices actually. So it's not really a question of whether we like it or not, but I see this trend happening, also enabling further use cases like crunching the data, detecting behavioral patterns to make suggestions, to like saying, well, you have switched on and off your lights every morning and evening. Would you like to automate it maybe? And adding more number crunching power to those gateways is something about costs at the end. And I see that there's a trend to move that to the cloud, because you're not using this computing power all the time. So they rather like to save money on that on the edge devices itself. So this is my current observation, what's happening, and I guess we'll see what happens after that.
So let me challenge you right there.
Of course.
Because I love when panels get a bit more lively. Recently, one of the big players in consumer and IoT devices demonstrated a popular device. It was a watch that had an extra feature besides all the metrics it collected and the data it tracked about you, sleeping, ECG patterns, whatever. It also featured the ability to detect a fall. So if you fall, if you slip and fall in the bathroom, for example, it was able to automatically connect to emergency services. But I'm from an engineering background, and I know most of us are. It's a difficult thing to do, and it requires power. That kind of mission criticality, do you see it happening more? And that's an open question to the rest of the panel. Do you see those use cases coming in more? And when we have mission criticality, can we afford to put things in the cloud, or do we need to crunch it? I mean, what happens if I don't have internet and I fall in the bathroom?
Obviously, and that's the developer speaking and myself, it doesn't work in that case. So there are use cases where you simply cannot afford to rely on a working internet connection, that's true. However, the very positive aspect about this use case is that it actually is a really valid, really important use case for many people, and that's what Brennan, I think you have been pointing to, is that we need these use cases to pop up and to develop such use cases, because IoT in the end is not just about the fun of making your lights green or yellow, but it's about solving real-world problems, and that's a really good case where they started with this real-world problem and had to make the decision it has to work locally. And we will have such use cases, and we'll continue to have such use cases. That's definitely true. However, not every use case is such a mission-critical one, and for those convenience features, where you want it primarily to be cheap and affordable, there I see this the other trend.
I agree, and the watch itself as an edge computing device, I think one of the things that we have done is our microcontrollers and these edge devices have gotten more powerful. Compare an Arduino from 5 years ago versus any single board computer or microcontroller today, and you have a more powerful edge capable device. There's been a tendency to say, oh, well, sure, let's run TensorFlow on that device. And, you know, we definitely want to push the limits academically and technologically with those types of things. But I think there is a difference between edge devices that are completely ingesting data, analyzing the data, and making decisions, which is sort of what we consider to be the holy grail in many cases. And it's probably a mistaken goal when there are lots of use cases where what ultimately happened in the case of the Apple Watch is Apple developed an algorithm, but they didn't do it on the watch. They developed an algorithm in their development centers. The edge device is just applying the algorithm to the data at hand to determine whether or not you've fallen. And any edge device that has that ability more than they had 5 years ago, I think that's the interesting piece that's new, is that edge devices that are smart enough to have a model or an algorithm that they have to look at the data that comes in and then to make a decision without going to the cloud. But as Simone said, there are still a ton of cases where the cloud and its computing power provides a ton more insight and a ton more data at scale to be able to give you actionable intelligence that may not be as instantaneous or mission critical, but still important to have.
And it's a great that you mentioned specifically use cases, how they evolved, how they consume. I wanted to talk about market trends a bit, because that's the driving force behind some of these use cases that we see. Iancho, here's a headline. It's an old headline, 2016, okay. But the headline from a big journal in the media was, "The smart everything trend has officially turned stupid." It was about an early attempt specifically to make an internet-connected refrigerator. But I do get asked this question a lot when I talk publicly at a forum. Why do we want an internet-enabled toaster, and why do we want an internet-enabled dishwasher that you can right now buy? Isn't this... people do understand the use case about reducing energy. I think people connect with that, specifically in the Balkans maybe, but also environmentally conscious users that we see more often. But they don't necessarily see why they need to put their toothbrush on the internet. Yeah. Of course, the reason is simple. It's now cheaper to do so and get perhaps a marginally useful data out of that toothbrush than not to put that. The market is driving the trend of the connectivity, the chips, the ability to put that thing is there is driving it. Do you agree? In your talks with clients, customers, do you see this trend?
Yeah. I mainly focus on the why, and I would say that the problem is a little bit even broader. It's not if the user understands the use case of the toothbrush connected to the internet, it's actually is there a reasonable use case for it in the first place. So it's one step before. The guys that designed it and decided that there will be some reasonable value from this, and people will make benefit of it. But to reflect on this, let me come back on the edge topic and to reflect on the why question. The edge, again, is even a broader paradigm. So it's a metaphor of like outsourcing some of the work within the IoT, and I would say IoT-enabled systems, because mostly we're talking about IoT-enabled systems. Outsourcing it from the cloud, where it mainly happens, to the edge, which is somewhere on the verge between the place that the things happen and the cloud. And the question why is brings to actually what value does this provide. So one part of the benefits are technical. So actually, if you imagine Industry 4.0 and industrial implementation of IoT-enabled systems, then at some point you get enormous amounts of data. You get enormous amounts of calculations that are needed, etc. So this brings a lot of traffic to the cloud, and it brings a lot of sometimes not meaningful to be done centralized calculations, because you do, for example, monitoring, or you do management of the specific factory. In the cloud is your whole system with the information of all factories. And imagine that you're doing monitoring. Does it make sense to send the data about like, I don't know, 10 specific sensors, to send it to the cloud so that you decide and understand that there is a potential problem based on this information? So it's a lot of traffic. It's really bringing significant challenges for infrastructure. So this is one thing, for example, as a technical driver for edge. And edge, in the broader perspective, could mean not only devices per se, but actually area, because you might want to do your small data center on the edge of your factory. It totally makes sense for enormous companies with big factories, and we see it happening. So there are quite a few, and the other thing is do the calculations there, alarm if it's necessary, or make the use of the IoT-enabled system, and don't bother with the cloud. So there are other also technical benefits that we can get into details. The second major, for me, type of enabler of edge is also for things like significant issues. Maybe here we are on different opinions about or challenges with IoT. For example, privacy. So we see that actually with IoT, with consumer IoT, I don't know, you should stop me at some point. So with consumer IoT, a lot of private information goes directly somewhere, to this system, to this provider, or to that provider. So you have a watch, if you have sensors about your heart rate, etc. If you have a smart home there, imagine that it's direct information about you. You can think about what Cambridge Analytica did only based on your preferences in Facebook, and like not direct but indirect information about you. So they managed to create the digital twin of you in an enough precision so that they can drive you in the way that they want. So now imagine that it's not indirect information, but direct information about you. So we are ahead of providing a digital us to different places. That brings a lot of opportunities, according to me, but also a lot of risks. And for example, edge, and I'm finishing, edge, for example, is something that can help, because in some cases, you might want to provide either anonymized or already processed information for the system that you're using. For your smartphone, for example, you might want to provide like the calculations that are done to go to the cloud after they are being done, so that you don't provide the digital twin of you, but provide the actionable information to the cloud and to the core system. So when talking about why it makes sense, for example, this is my thinking about Edge specifically. Does it make sense to you? What do you think?
It makes absolute sense. The reason why I started with the Edge is because I wanted to set the stage. We have the sensors in the IoT devices everywhere, factories, consumer. We have the cloud, chunking the data, churning the data. We have the customers, the consumers, the producers of devices. Now we have this concept of Edge that processes some of the data closer to the origin of data. And we have all these forces between them of who cares about the raw data, the privacy, how we can process it, how we can anonymize it, what we can do with it, in what latency. And setting the stage, what do you think, let's talk about the impact. The next part of our conversation, I really wanted to talk about the impact, and I mean impact for specifically our audience, which is technical. There are a lot of developers in the audience. There are a lot of quality engineers. The legacy of this conference, it started as a conference dedicated to how we test things. Now, of course, because that role has changed over time, we no longer do just quality assurance. We do quality engineering, we test, and now we develop. So the conference has changed, and we talk about the whole development process of software. What is the impact of Edge, IoT, these forces, these market trends that you talked about, to those people?
Maybe I can start because I will be the least technical. So my impression is, because I'm not hands-on like for 5-6 years already, my impression from the projects that I'm personally responsible for and from what I see works is that a little bit on the contrary of what you mentioned about JavaScript. I think that things like low-level programming, good understanding of networking in general, with deep dive, like hands-on experience in it. Another thing is with all those, how should I say, working with limited resources, be it on edge devices or whatever embedded programming you need to do, you really need to take care about quality. I mean, you really need to do optimized development for both availability, for speed, for resilience, and things like this. So I would say, again, as an old school practitioner, the core things about a good software developer are like exponentially more important for IoT-enabled systems and projects. And from the point of view of testing and quality assurance, rather, I would say it's more or less the same. There are many challenges there because you have devices. I think both of you mentioned in your presentations about the fact that you have different vendors, you have different firmwares, like not different, but coming new versions of firmwares. So if you don't plan really well, if you don't have a really good strategy, if you don't have business decisions taken, like you need to let go some part, like Android, I don't know, 5 years ago version or something like this, you would be doomed to failure. So with this, the added and maybe very interesting thing is about the fact that we're talking about things. So those are like things that you touch, etc. So sometimes there are many things that you want to do physically in order to test. So some robotics and things like this are also in the broader context of testing well IoT applications. And we live with this, and it's really interesting. Maybe you can.
I fully agree to what you said. I would like to add from a technical perspective that what I observe is that what we had as a full stack developer, like developing UIs and backend and database, that somehow changed when you are running on your software on devices with such restrictions, because suddenly what the full stack means is something completely different. As you said, you will have to deal with native code, or native parts of the operating system, although you never planned to because you thought you were a Java developer. And at the same time, maybe you won't deal with database in the classical senses anymore in such a small device, but you have specialized key value storage for certain use cases, which maybe nobody uses in the same way you did, or you have to. And as all this are only small parts, you cannot afford to have people specialized on such a small thing like a key value store. So you end up having to know everything, and that's a really interesting thing for us developers, is that the area of expertise is so huge. Another aspect there which I observe is that the boundaries between development, QA, operations really melt down, and you really, although you have specialized on something, you end up being really close to all the other professions and really talking closely to each other, and probably having or doing tasks that originally were not part of your personal job description. Or so as a developer, you will also be faced with testing things, and as a tester, you will definitely be faced with lots of code and ugly problems that were never actually meant to be restricted to testing only. So,
which is actually a great thing, because I think that's the way a team should be.
And that's what makes work interesting.
But now that you mentioned, and we'll get back to the developers specifically about the edge, because I have a question for you. But first, I wanted to talk to Simon about. All right, these and Iancho, these talk great. It sounds great, but don't you see a kind of a dichotomy of forces clashing? I mean, on the software engineering side, right now we are used to agile. That has replaced, in many cases, our waterfall models of the past. We're used to DevOps. We push and we have continuous development, deployment into production. There are DevSecOps, so we test against production security vulnerabilities or whatnot. And at the same time, the world of IoT is becoming more ubiquitous, more critical. I don't want my dishwasher to fail, especially because I will have to wash all that, or even worse, I don't want the factory to fail. And so on one hand, we are moving faster as a software engineering community with all our processes. On the other hand, we have these, software is no longer virtual, but it can be quite physically painful if we get it wrong. How do we resolve that? It's an open question for...
Sorry, but I don't understand the question.
Okay.
Because I don't think the type of, the first part that you described leads to something that is not like connected to the second part. It's not now. I mean, it's not IoT, it's not the dishwasher, it's not the, for example, the device that tracks if there is smoke, so I'm eluding the English word. People sent other people to the moon, like tens of years ago. They didn't have almost anything that we can imagine and we take for granted now. There have been ATM machines providing money to people for many, many years. So there are so many cases and so many types of projects and systems where this resilience is already needed. And I don't think that actually agile or whatever, like quick releases, etc., it depends on the strategy for the project. So it's about the project leader and the main stakeholders that set the bar for quality, for resilience, etc. And then you decide to what extent you go Scrum or Kanban, or we release each 2 weeks or each 2 months or whatever. So what I wanted to say is that I don't see this as a problem. I think that on a higher level, the analysis and the decision how we go in this and that situation anyway needs to be done. And if it fits waterfall, then fine.
I think I think part of where the question comes from, and I had the same thought about the first space shuttles, and I mean, we've been building mission critical systems with software for 70 plus years. We know how to do it. I mentioned this morning in my talk that the internet democratized development. One of the sort of dirty little secrets to that is the internet democratized bad software development in a lot of ways. It's never been easier for us to write terrible systems.
Good that we had a second session with you, so that you
but that's the reality. That's why you need process. That's why you need teams that sit down and say, it's not about we're going to be Scrum or Agile and now that solves our problems, because those processes never were the answer. It was having a strategy, having teams that understand roles and coming together, and allowing the industry to respond. I mean, one of the things that I like about the history of this conference, that whether it's QA or DevOps or site reliability engineering, those roles are very critical to the success of software in general, but very specific to the Internet of Things, because the complexity of the kinds of systems we're building have been amped up in the Internet of Things. There are more devices, there are more places that we have to look at. Every device that's connected to the internet is an attack surface and a potentially vulnerable piece of equipment. And the folks in those roles are the ones that are going to make sure we build resilient systems, because they're thinking about how to manage the complexity, how to implement the right level of networking, how to make sure the processes are in place, that when we apply firmware updates that they're tested, how we even think about managing virtual devices for testing and things like that. And all of that is definitely, I think, an area where those roles add a lot of value into this space in the future.
Absolutely, and what you say is leading me to the next impact of IoT and Edge, and that would be, let me paraphrase the FCC chairman, who last year, former chairman, he quipped that we are right now discussing 21st century issues with 20th century terms and proposing 19th century solutions. And it's a fun saying, but the gist of it is we are not allowed to do, luckily, everything that we want with our software development processes, deployment of firmwares or whatnot. There are sectors that are heavily regulated. Look at the energy power plants. I cannot just update their machines. I don't know about ATMs, but the process to build the space shuttle software and the Apollo moon missions was quite different from what we have now, for a reason. And also the process that is being used for airplanes, the software that goes into an airplane, is also quite different. So, and that's regulated. There are some regulations what specific assurances there needs to be from software that runs on car ECUs. Now, having said that, what do you think are the next regulations that are going to affect us, both us as developers, us as consumers, us as professionals in the IoT space?
Maybe I can take it, or
No, that's good.
yeah. I'm generally not afraid that much of regulations. You should hear what FCC is talking about cryptocurrencies and blockchain, so even more funny stuff there. I'll just drive it to a little bit different direction. So I do believe that governments have a critical role in the future of meaningful IoT and in general innovative solutions. For example, there are countries now with not strategies on a paper, which many of us are used to, having something on a paper and then nothing happens, but countries that are actually investing in this. And I myself, for example, believe that the smart home market would kick off really when it is being marketed at scale. So what, for example, the smart home market is still lacking is significant adoption, because it's retail business. So you sell the idea to different people. What I believe will work is with the the growing, not trend, but the growing reality of smart cities. You have countries like China, for example, that they have a plan to have 100 smart cities, newly built smart cities, by the end of this decade. You have Singapore that is doing a lot of things in this area also. You have Saudi Arabia that are also building. So you do it at scale. So you don't convince somebody to do it, but you build you build the things in the new way. So the country, those countries, for example, and those are just a few examples, but in general, having the support of the country to realize some of the benefits or the promises of an innovative technology or innovative enabler such as IoT is something that I believe is a really good thing. I'll give you also another example that is just in my mind about regulations. It's a regulation that I think could actually help. I mentioned digital twins. So maybe most of you know PSD2, the regulation that says currently if I have a bank account in bank X, and if I decide to share the data of everything about my bank account, my transactions, whatever, credits, history, to another entity, be it another bank or anything else, this bank, Bank X, is required to do it. They cannot say, this is my information, I don't want to share it to competitors. So you can do it. And this is an enabling regulation. And for example, what I imagine in my mind is that those, the opportunities that IoT provides with, I mean, we talked about the threats of having a digital twin of you and somebody getting information about this can do really bad things. But on the other hand, if you can imagine, so your watch sends information to Apple, for example, you have a Garmin or you have different things. So you have a lot of things that know pieces of you, pieces of your history, your everything in like disparate locations. So I believe at some point there will be something like PSD2 for this also. And at this point, if you can think about healthcare, for example, so your doctor will be able to say, okay, you give me like allowance to use all your data in different places, and I see how often you go to sleep, I see your heart rate or whatever. So this kind of interoperability between different storages of data at some point as a regulation is something that I hope and I imagine that, that it will happen. So I don't regard regulations or governmental bodies as like burdens, but rather hopefully, because we see examples, as enablers also for innovation that makes sense. And one last sentence. I told you that there is some controversy. My take on the hype cycle is that we are already somewhere, like for the audience, we are already somewhere here, not going down. And I can tell you why, because when you say I'm working on an IoT project or it's an IoT system, people will tell you what specifically. If you say I'm working on a blockchain, most of the what will be, what the hell do you mean? So currently IoT is almost everywhere. So we see like real industries, especially with Industry 4.0, reaping real results from it. We see acceptance in terms of people are not afraid. People know about those things. We see people and whole regions and whole countries investing in it. So I'm sure that it's something that there's no way back, and also there are like tangible benefits of it. Yes, there are also smart/stupid implementations that don't make sense. I mean, the makers would argue that the users don't understand their great idea, but actually it's a toothbrush, smart toothbrush. Okay.
I think that's a fair interpretation. It's not, I think, untoward to suggest that maybe we're further along the hype cycle than analysts and others would suggest. I think I tend to feel like it is further back because of those types of useless innovations we see. And perhaps most of those are isolated to Silicon Valley startups in the United States these days and Kickstarter projects and what have you. But I do still think that where we move the rest of the way there, whether we're now getting there or whether we still have a ways to go, regulation is a big piece of it. And I think one of the ways that we enable that is by actually having standards that coalesce. And I can use the smart home as an example, but smart home standards, and part of the reason why the smart home has been such an issue in taking off for so long is because every vendor has their own standard and they want everyone else to follow it and no one else is interested. So you have Samsung Smart Hub, now you have Amazon's Alexa, you have Google Home. Everybody has their own standard, and I think what we're starting to see with certain types of standards like OpenThread and Zigbee actually starting to talk about interoperability, when we get standards and when we get adapters, much like in any country in the world, you may have a socket that works in your country, and all you need is an adapter in order to get mains power out of any other place anywhere else in the world. When we get to that point of standards and adapters, I think we'll see the smart home take off. I do think smart cities will actually drive that more, because the reason why that makes sense to me is because smart city adoption tends to be top down, consumer adoption tends to be bottom up.
And at scale.
And at scale, absolutely.
By the way, while we talk, let's open the floor for some questions. There are probably mics around the room, but we can continue to dig deeper into this, because regulations can, yes, they can certainly affect standards of what we do. There might not be, perhaps in the foreseeable future, also regulations in terms of ethics that would be required of software development teams on how we approached IoT devices because of privacy implications, because of implications to human life, and the ability to affect it. Simon, what do you think when you talk to? It's a bit of a controversial topic, but
no, that's indeed an interesting point, because if you make market studies and if you ask people, hey, how much do you care about data privacy, about other ethical topics, everybody would agree, yeah, data privacy is very important to me. However, that doesn't explain to me why Facebook's such a success, why Google is such a success. So in the end, if there is something of value to get out of that, we are prone to compromising on such things like data privacy, as long as we have the feeling, or actually the trust, that the companies, what they are doing with the data, is to what we would accept as, what we think is acceptable. So when we provide data to Facebook, we trust Facebook that they keep the data for themselves and not share them with other companies with different interests. And I think it's the same in the smart home market here, that the much more important factor of that is trust. Trusting in the providers, because in the end, technically it doesn't make much of a difference if data is stored on an edge device or if it's stored in the cloud, when the same company that runs the cloud also provides the firmware for the gateways. So in both cases, we, as a consumer, I have to trust this company, and that's something where regulations, of course, help. I mean, we have very strict data privacy rules now in Europe, which are really for the better, I think. And it doesn't keep us from doing the cool stuff. We just need to make it transparent to the users. And the same would be with security. I mean, that's something where I see that maybe some regulations might come up in future. Regarding wireless communication within the home, for example, there are vendors who don't care much currently about encrypting radio messages and all that. I would expect that one day there will be a regulation on that as well. However, it's going to be a challenge for us as a developer again, because I've never ever seen a case where adding additional security makes things more usable for the end user who doesn't want to be bothered with that security, just wants it to be secure. So that's where we are questions again, to come up with good and working solutions for everybody.
Do we have any questions for our guests? In that case,
I can add something to the previous question. Not just because I talk old, but last year I was at a conference in Germany, and a similar one, and I attended a topic that was specifically targeted at ethics for development. And what I think is important to be said is, I remember the example that they said, there is a company sorry if it doesn't sound good, but it's a company that enables euthanasia. So they built a device that allow you to take your life. And there's software in it, and etc. So the ethical question is, if you are a software developer and you believe that this is not a humane thing, human thing to do, what should you do if it's your company, etc. So there, like, ethics is really, really important to me in general, and what I wanted to add is the personal perspective, because we're all practitioners here. So it boils down to your own decision. You should live up to your values, to your understanding, because also Dieselgate and all those other things, somebody wrote the software, but not only like was lazy and didn't add security, whatever, no, on purpose, understandingly, wrote the things that tricked the evaluation process. So the question and the important thing for us is to have this understanding that we have values and we are people first, we are citizens first, and then professionals. So this is one thing that I believe everybody should care about. And second, an enabler is the company to publicly and internally very strongly state as much as possible their values and the fact that you are not going beyond some borders. Because this allows us, as much as it's talked, the more it's talked about, the more public, the harder somebody will go after it, although pushed by the CEO or somebody else. So that was my take on it. Sorry to...
No, it's great. I like to be able to finish on a high note like that. Any final remarks regarding?
I would love to add to that, because when I talked this morning about solving real problems, the things that get me excited and get me out of bed every day to solve problems in the IoT space are the things that we care about as human beings, the things that make this earth a better place to live in, the things that are designed to help us better serve one another. We have to be vigilant as developers and as technologists when this technology can be used for ill or for good, and that's been the case since the beginning of software, since the beginning of mankind. And so we have an opportunity to work on the things that drive us, that we're passionate about, and the things that we think actually help. And I think the IoT is a place where there's a ton of that kind of opportunity, and I encourage everyone to look for those and jump in with both feet, because it's an exciting time to be a developer.
I cannot agree more. There are really, really interesting things coming up now with the fifth generation mobile protocols, with narrowband IoT enabling more and more devices and use cases that we currently probably even cannot think of. I mean, if you would have asked 30 years ago what will happen when you introduce the HTTP protocol, yeah, well, you can read web pages, great. As always, there will be really, really interesting times, I think, especially in this area in the next couple of 5 to 10 years.
Perfect. Thank you very much. Let's thank our speakers.